team coming to this presentation. Perception and knowledge about the use of biological indicators in freshwater ecosystem monitoring in Rwanda. As Vena said, this is a part of my PhD research, and this is also published in the African Journal of Aquatic Science. Freshwater ecosystem, mainly wetland, lakes, river, stream. They are very important for different use, including power generation, drinking, agriculture irrigation, and fisheries. Despite this importance, they are under pressure due to human activities, and including agriculture, urban settlement. Those are the main activities that put under pressure water sources here in Rwanda. And the freshwater species, they are also threatened as the water resources is threatened by those different activities as we mentioned. To address the problem related to pollution, Rwanda has established different mechanisms, including monitoring station, relocation of industries from watershed to special economic zone. This was done just to reduce wetland and biodiversity degradation, and also to make sure that all municipal wastes, they are just collected easily, or they are drained in a way that they cannot harm the water quality. They also initiated the legal framework and the policies for conservation, protection, and the management of water resources. Besides that, they develop water quality baseline for different parts here in Rwanda, but mainly they are focusing on physicochemical parameters and the bacteriological parameters. Despite those mechanisms, there appear to be a gap in the use of biological indicators, and those biological indicators, they are very important to indicate either the current situation or long-term change in water resources. Biological indicators are efficient in providing information about both current and long-term change, and they are applied in several developed countries, and of course some developing countries. In Africa, South Africa is the most leading in using biological indicators. Nevertheless, once you look here in Rwanda, this part of using biological indicators is still to be adopted, means that we are just lagging behind. For the objective of this study, we are just need to explore feasibility of including biomonitoring using biological indicators as a fundamental part of water quality monitoring in Rwanda. Specifically to assess understanding of participant practicing water management professionals about biological indicators and their potential to support and complement current physicochemical parameters in Rwanda. We use qualitative research as to using semi-structure interview and the purposive sampling to assess perception and knowledge about biological indicators, challenges, what are the challenges for their integration into water quality monitoring. And this study was conducted in August 2021. To conduct this research, we selected first the different institutions that related to water resources and the water quality assessment, and also some institutions that make a decision on the use of water resources. And among those contacted institutions, we selected main institutions that have influence in water quality monitoring, but also in water policy development. So here we selected the MINAGRI, Minister of Environment, NIRDA, LEMA, Rwanda Water Board, and the University of Rwanda. And among those different institutions, we select staff working for government institutions actively involved in water resources management in Rwanda. And those staff, they are selected based on their position, experience, and the expertise, of course, expertise in the water quality assessment. Interview guide questions were developed as part of each sub-structure interview, and they were tested, revised, and validated before it was used among our key informants. Semi-structure interview were used for data collection, and the thematic approach was used for data analysis. And of course, as we use English and the Kinyarwanda, those recorded in the Kinyarwanda was transcribed and translated into English. As a result, our respondent mentioned different organisms, including macroinvertebrates, algae, and fish as part of the organisms that can be used to monitor water quality monitoring in Rwanda. Our participants link presence or absence of macroinvertebrate with water quality, where they said that once they found a variety of macroinvertebrate, they can conclude that water is of good quality. But when the number of species is reduced, they conclude that water is polluted. For algae, participants mark algae such as diatoms as indicator for eutrophication in water bodies. For example, one of them has reported that in the case of water is receiving a lot of nutrient, only kind of domestic pollutant, we observe a lot of algae growing and developing exponentially in water. Those are biological indicators of eutrophication. Here, for this, I try to capture some genera. Of course, those are the species from my working area, especially in the Akagera River. Some genera that can use to indicate pollution indicators, especially high nutrient condition. For fish, participants link fish presence or absence to water pollution, while others link them to variation in season. Here, for example, we have fish, Protopterus aetopicus imamba in the Rwanda. Once they see this fish, of course, in their abundance, they say that water is not good, and the rain season is approaching, and the quantity of water also is increasing. While presence of Oreochromis neoticus, this was linked to water quality, means that water is good, and dry season also is approaching. Among the challenges they mentioned the tools and the materials. Here, for example, I have different image. I have this image from electronic microscope that we don't have here in Rwanda. And we don't have this microscope that you can have camera in order just to visualize all different details. So our respondent stated that when you bring another indicators, new methodology is needed, expertise and even equipment, they are needed just to enhance this use of biological indicators. The second challenges is financial resources. Mainly this finance can be used to increase capacity building. You see for these photos, I've taken these photos from Belgium, where I was just trained to identify diatoms. Participants said that once we would like to add biological indicators if we have financial and technical capacity, because this need to have personnel which are trained in the taxonomy and also how to identify those species. The third challenge is technical skills and knowledge, and this also was linked on how we can develop clear methodology and a protocol that can help just to assess and disseminate those biological indicators. Although even if our key informant, they know some organisms that can be used as biological indicators, there is still gap in their knowledge because they don't know, they don't have knowledge about the taxonomy, means that they cannot just indicate at which level those organisms that can indicate pollution, which degree of water pollution. Even if a participant have overall understanding, they don't have also knowledge, detailed knowledge about which specific aspect. Either can we use presence, can we use absence, abundance, species richness, or diversity? Means that there is just a gap in their knowledge. Although they have this gap, there is some existing research that indicates example for macroinvertebrates that can be used as indicator of concentration of organic materials and nutrient. Here for some examples of algae like Chlamydomonas, Euglena, Navicula. Those are reported to indicate water pollution with organic matter. While for fish, Orechromys neuroticus, it can be used as indicator of water quality, while Protopterus, it can indicate water pollution. So as recommendation, we are recommending that we need more training and awareness to build capacity of water managers in the use of biological indicators, link Rwanda professionals with those undertaking similar biological monitoring programs elsewhere, integrate the work going on the country to develop taxonomy expertise and indices for biological indicators into their program. So I would like to thank different partners that help us to perform this work, including University of Rwanda, Center of Excellence, NZARORA Water Center, and the African Research University Alliance, and the Global Challenges Research Fund. Thank you all for your kind attention, and any comment, suggestion for further research are welcome. Thank you.
Yeah, thank you very much. I'd like to thank you very much, Alphonse, for this presentation. I want to first of all hear from the audience. I want them to just raise hands and speak or write in the chat room for any question or comments. You are welcome, colleagues. I don't see many questions, but Alphonse, I need
Hey.
Hey. Yes. Jaime, you are welcome.
Good. Thank you so much, everyone, and also particularly for Alphonse for this nice presentation. I was very curious to ask if Alphonse, you can give us a kind of information, or maybe if you know some, if you have idea already, how we can use this information to help to design like a kind of conservation that is taking account the economic return. So what we are losing if we don't really take into consideration these aspects of biological indicators you presented. So did you thought about this to try to bring facts like economically what does it mean, and what is the gain or the loss in terms of this economic kind of information? I'm not sure if you can understand the question or if I'm clear enough.
Thank you, Jaime. I understand your question just about what if we didn't consider those biological indicators, what we are losing in terms of economic. Of course, as I said, the use of biological indicators here in Rwanda, it is just we are lagging behind. But of course, as conservationists, we need just first to know what we have. As I started myself on datums, and I know some others working on macroinvertebrates, including Gilbert. I know maybe he's present in this presentation. So we need first just to know what we have and see how we can even valorize them in order just to communicate to decision makers to see the value, because those biological indicators, they can be viewed as an added value, especially in terms of water quality monitoring, because remember here in Rwanda we are just doing water quality monitoring, especially by looking on our physical chemical parameters. But once we valorize those biological indicators, it can be also an added value. So we need first to recognize what you have. So we are just starting because we are trying to, as in center, we have started just to recognize those different species, especially those neglected, because looking on macroinvertebrate diatoms, you see most of they are the smallest, but as the one that can have even important in a web, they are very important just to valorize them. I don't know if I just give a picture of what you are asking. Thank you.
Yeah. I think it's yeah. You managed to answer the question. I think it's very important that we bring these facts like to how do we use the biological indicators to turn this information into economic information that can help decision makers to take decisions, because this is very important. So maybe in the future you can explore more of this. So we are trying to make the same for pollinators, for example. So, or maybe for other arthropods, biodiversity, like the decomposers, how they are trying to bring in a kind of their contribution to nutrient cycling, and then how this is impacting the productivity. So it's very important that we link this information with the economic value of these biological indicators, so that we can try to to see if we can really convince or maybe bring facts that is really kind of tangible, I would say, if I can say. Thank you so much for the answer. Yeah.
Can I ask a question?
Yes, you're welcome.
Thank you, Alphonse. That was a great presentation. So I didn't catch well how those fish are like indicators for like pollution. I think if I remember well, they are both like introduced species. And yeah, I didn't. Can you tell us like details on how one fish can tell us it is like a good water, and another tell us it's a like polluted water? Not that they are maybe like invasive species, something like that. Thank you.
Thank you for the question. So, first of all, once we talk about the biological indicators, we know that those are organisms living in the aquatic environment. This is first, because depending on what happening around, the species can be present or absent. If maybe a given species, here we are talking maybe on the two species of fish. Let's start on this Protopterus atypicus. Mainly here in Rwanda, even if it is not native, I think, once it is found in especially for the fishermen, once they are found it in their catching, for them, it indicates that the water is not good, because looking on the abundance or the numbers of those two fishes, they are available in different way regarding on how the water it is. Especially this imamba, mainly it is found in the mud, especially wetland after just the rain season. Means that for them, once they are found them in their catching, it means that water is not good, and also the rain season is approaching. Where this Orychromis neuroticus, once the turbidity of water is somehow reduced, it is where they can find this fish in their catchment. Means that their presence or absence, it just indicates how water is, either good or bad. I don't know if I give the answer for your question.
Yes. So it's like an indicator for the turbidity of the water or the nutrient content. Like, can we say, for example, if we find like or the chromis, like the water is not polluted chemically, or it's just like turbidity and erosion?
Mainly here, regarding on this research, once this Orychromis neuroticus, they are mainly looking on turbidity, because looking on the fisherman, they don't know just to measure those chemical parameters, but looking on how water is, especially they are looking on the color of water. But for the Protopterus atypicus, main, and even I remember myself, once I visited different sites on the rivers Akagera. If the turbidity is somehow reduced, means that the water seems to be clear, we can just find those Orychromis neuroticus. But once we found water which is having more turbidity means that the color is not clear, and where there is mud, especially in wetland, which is where we can find this Protectorus atypicus. Means that depending on the level of pollution, some fish may disappear and others may arise their abundance. Thank you.
Thank you.
Can I ask a small question?
Thank you very much for those of you who are asking. There is someone who wants to come in.
Yes, Vena.
Yes,
Can
please.
you hear me? Okay.
I hear you very well.
Yes, thank you, Vena, and thank you, Alphonse, for your presentation. I have a small question. Maybe it is a follow-up to the first question, or maybe it's linked to it. You stated in your presentation that water quality monitoring in Rwanda do not include this approach. I mean,
Bioindicators or
yeah,
biological indicators.
bioindicators. Yes. And I think it's one due to budget constraint. And I would like to hear from you, because these biological indicators, or no, physicochemical parameters you said, and even the biological one, they reflect what is happening in the freshwater ecosystem, whether it's a river or whatever. Yeah. So that means if maybe we find this pH nutrients in this amount, it reflects what is happening in that ecosystem. So I would like to understand, what really do we lack in terms of knowledge when you don't include these your approach or these biological indicators, so that we convince really the policy makers to include your approach in our practices, because it's money wise. I mean, I think, and everything of course comes to money. So how would you because if at least we can do physicochemical and biological monitoring and frequently, so what else this approach would add? What value is added? Or what do we miss if we don't include? Thank you.
Thank you very much.
And before maybe you come in, I think we also lack to monitor the emergent pollutants. I don't know if you know them. For example, microplastics, which is really an issue. Maybe in Rwanda, if you maybe we talk about pharmaceuticals and so forth, we don't monitor them yet. They might be in our water bodies. So I don't know. Yeah. So you understand what I mean?
Yeah.
Thank you. Yeah.
So thank you. Let's start with this issue. If we don't have these biological indicators, what we miss? Mainly looking on our physical chemical parameters, I can say this is good. But let's start with tomorrow here in Rwanda. We have experienced rain during the day. If you are gonna just to measure those physical chemical parameters in the morning, and the one coming in the evening, if you look on those parameters, the quantity, the quality, we are saying that we have different measurement. Once means that those physical chemical parameters report the exact what we are measuring at the moment. But looking on the change even of the day, there is lot of change. Means that if we are putting, for example, something into water, maybe it is a river, as it is flowing, one can measure at this moment saying that this water is polluted. But coming in the evening, taking the same measurement, you can say this water is good. Of course, looking on those physical chemical parameters or on the range, what you are just reading at this moment. But looking on those biological indicators as the organism living in water, they can just tell us about the current situation, but also they can even predict what should happen in the future. For example, in order just to understand what I am telling, let's suppose in a given area, there is maybe industrial waste charge in that area. You'll see that there is some species which may appear that area which can tolerate this environment, and the others, if it is aquatic environment. Remember that if there is any change, either some species need to adapt, others need to live. So if they are not able to live, either they need just to tolerate that environment and others may not tolerate. So that we need just to complement those physical chemical parameters with biological indicators in order just to have a full picture of the water resources. And also looking on our biological indicators, sometimes you see that most they can even accumulate those pollutants. So looking on our environment, we can say this water is good. But by looking or by assessing those biological indicators, they can even indicate the level at which the area is polluted, especially by looking on accumulation of the pollutant. Either it can be heavy metals. You know that some organisms, especially the plant, the atoms, they can accumulate the pollutant that those parameters, those tools we are using to measure physical chemical parameters, they are not able to detect. But those organisms, as they can accumulate those pollutant that can be not be detected by those tools we are using to measure physical chemicals, so we can just have those biological indicators as an added value. Thank you.
Thank you.
Thank you very much, Alphonse. You explained it well and clearly. I saw the hand from Gilbert. Yes, Gilbert, you are welcome to come in.
Thank you very much. Am I audible very well?
Yes, very well. And long time so far.
Yeah.
Hope you are good there.
Yes, I'm good. I'm doing well. And I was enjoying the conversation and the presentation of Alphonse. Thank you, Alphonse, for a very informative presentation about bioindicators. It was really needed, and our authorities, many people need to know about bioindication so that we can apply it in conservation of aquatic resources, but also in economic way. There is, I don't remember if it's Jean-Aimé who asked about validation of like use of this bioindication in economic perspective. I want to reflect on that, but also emphasize the use of this bioindication over the traditional method of assessment of water quality or maybe ecosystem health. These bioindication or organisms have ability of showing all signs, the thing which can't be described by these physicochemical parameters. I will not go further because Alphonse has already explained very well, but I wanted to add this fact that these organisms have particular potential of showing Alzheimer's. The thing which can predict also the future of ecosystem, which can't be shown by these physicochemical parameters. So that is the important thing. Another fact is this bioremediation. Some organisms like macroinvertebrates can accumulate heavy metals or even the other pollutant of emerging concern, which also an added value to these organisms. Considering this biomonitoring, not only assessment of health quality, water quality, health of the ecosystem, it can also give us a glimpse or reason why we need to conserve these organisms. Because some of these organisms are threatened, others are endangered. So to have them in mind, we need to reflect their role, not only being there as organisms, but also to try to tackle all of their essence or their role in the ecosystem, including this one assessment, bioremediation, to give us reason enough to conserve them because many are threatened. For example, we don't have a list of macroinvertebrates which are endangered there because we still have issues in taxonomy, the general case in Africa, not only in Rwanda, but also we need to at least have one step further to apply them using different aspects like indices. There are some developed indices in different regions, though we don't have it in Rwanda, but we have some indices reflecting macroinvertebrates, for example, in Tanzania, in Kenya, in South Africa, the one we are applying. So all those indicate how people are concerned in shifting from traditional use of assessment of water to bioindication. Economically, also, I want to bring this aspect of ecosystem services that provided by these organisms, in both algae in terms of food chain or retention of those pollutants, purification of water, whatever. All those are essential things that we need to highlight while talking about these organisms. So I want to highlight on that and thank Alphonse once again. Also, encouraging others to use biomonitoring, or not only in the fresh waters, but also there are some plants which are used in the phytoremediation and can indicate the pollutant in soil. We have also some research coming up indicating how microplastic are affecting some aquatic organisms. As one of the previous people who asked the question about pollutant of emerging concerns, they are also there. So really, those organisms in different ecosystems have a lot of importance that we need to tackle, to explore much to make use of them entirely. Thank you so much.
Thank you for completing the ideas. And I see that this presentation is very good, and the insight from your comment. Thank you, Gilbert.
You're welcome.
Thank you, Gilbert, for the inputs. They were very constructive. I want to see if there is anyone else who has a question or a comment before I close the seminar today. Maybe no. Let me close the seminar by thanking all of you for attending today. Thank you,
Yeah,
especially.
Bena, excuse me, Bena.
Yes.
So we've put some messages into inbox, so I don't know if you can read them. So
Okay. I don't
we've
see
sent some
well.
messages. We've sent
Ah,
some messages. So can you read them?
yes, I can read those messages. Sorry. Yes. The first message in the chat room was Beth, who was apologizing because he was about to leave. Then President Musi said, "Thanks, Alphonse, for the presentation. You have shown a number of challenges behind not using biological indicators. But in terms of priority, which challenge do you think can be addressed first according to you, and the others will follow?" Can you answer this question before you go on, Alphonse?
Thank you, Prasid, for the question. You see, among the challenges, though, I mentioned we have also challenge of uh, skills, financial, uh, what can be the first to be addressed. To me, it can be the challenge that the main challenge that can be solved. It is just the knowledge, but the knowledge gap it can be associated with equipment because let's suppose that if you have materials, if you don't have the person which will use those equipment, this can be a problem. Means that the material challenges can be associated with the skills and knowledge because we need expertise. But if we have those expertise maybe from abroad, if we don't have the materials just for us to continue this study, it will be also a big challenge. So we need just to associate um, knowledge, skills and knowledge with materials. So we need just to not to be separated, but to be associated. I don't know if Vena can we have the second one?
Yes, and I would like to thank you for that because, yes, you said it right because those challenges are somehow connected to one another, and it's not easy to say I am done with when I solve one challenge. They are somehow connected, and it's better if you go for them all at once. You said Aries, and I would say thank you, Alphonse, for the presentation. My question is this: are there some indicator species that are on the brink of extinction in Rwanda? If the pressure are not addressed, if there are some known species, what are they, and what are key recommendations for sustainable conservation?
Thank you, Eri. As just we are on the beginning, I think with the center we started that just to work on those neglected species, including macroinvertebrate algae. Of course, if the environment is under pressure, means that of course the species also will be following this pressure. Of course, for those biological indicators, some of them they may be extinct, but what we are just starting is just to make the baseline of what we have. And as we are just doing the biodiversity monitoring, we can see if there is some new species or if there is others that disappear depending on the pressure. So the recommendation is just to make the biodiversity monitoring regularly, especially by including those, not only considering the protected area. You see here in Rwanda, mainly we are focusing on the protected area, but those vulnerable environment, including rivers, wetland, it seems that we are not considering them, while those biological indicators, as we are saying, the most of them, we can look them in terms of ecological services, including wetland um, purification or water purification, or accumulating those different pollutants. So we need just to valorize or to consider those neglected organisms, not only to consider those macrophytes or macro animals. Thank you.
Yeah, thank you very much. Placid has the second question, which says, did all of your interviewees know about what a biological indicator for water quality assessment is, as per your presentation?
I can say no, because of all of them, they don't have the same understanding. Of course, there are some having more knowledge about biological indicators. There are others just understand, but really they don't know really what should be. Because as I said in my presentation, some of them, of course, if they see this species, they can link to water quality or good water or bad. They link dishes to pollution. And the others, they don't know if really they can use either abundance, species richness, diversity, or absence. So there is just different understanding. Thank you.
Yes, thank you very much, Alphonse. And I think now we are. Would you like to say something else, Alphonse?
I would just thank all the, if you are just finishing the question, to thank all the participants to this presentation, their input. So I really thank you for the coming and the giving input for this presentation. Thank you.
Thank you very much. Yeah, and thank you again for all of you who attend the seminar today. It's always a blessing to have you. Keep coming, keep just attending those seminars so we discuss and we learn from each other. Bye. See you next time.
ubwo ngubwo bivuze ngo ntago kwa gatanu umuntu yagushimuta